In this video we're looking at 11.76 from the textbook. We're looking at the snow geese feeding trial problem. So if you read through here to describe the data, but essentially what they want us to do is to work with this file that's in the textbook. The file is on a disk and it has a set of data called the snow geese data. And when you look at that, there's a set of values, 42 values in the data in Excel. I'm going to go over there and show you what that looks like in a minute. But for now, let's read what the first part of the question says. It says the botanists were interested in the correlation between two variables. They want weight change, which they want you to treat as your y variable, and the digestion efficiency, which they want you to treat as your x variable. And it says to plot the data first in a scatter diagram, and it asks, do you observe a trend? Well, to do that by hand is a little time consuming, so let's go ahead and do it with Excel. While we go look at the problem, I'll show you how to do that quickly. Okay, so I'm going to pull up the data in Excel. So here's the data set in Excel. We have weight change and digestion efficiency. Notice that they asked us to use weight change as the y and digestion efficiency as the x. I'm just going to do something here. I'm going to actually take this column here. I'm going to cut that column and I'm going to click here and then say insert. Cut cells. And what that does is just switches the order, because I like to normally see x then y. So if this is going to be my y, I want the x to be first. Okay, so I've done that. Next thing I'm going to do is I'm going to actually highlight these two columns. So I have both sets of data highlighted. Actually, I could do it either that or just kind of click and drag down to the 42 data sets are completely highlighted. And once I've done that, at the top of my Excel, which is a little off my screen here, but you can click Insert, and when you click Insert, you'll see charts, and you'll see this scatter diagram thing come up. So if I click that, and then I click this one with the dots, just the dots only, it'll produce the graph that we're looking for, just in a very simple two-click feature, right? So there it is. We have the two columns. They're telling us what values. If you look at the values, it'll even highlight over them and it'll tell you what value you're looking at. Like this is the 1, 3.5 value, so that would be this line right here, 1, 3.5. All right, but anyway, you can see the general pattern in the data. It seems like, if this is a number line, a standard number line, which is what they're showing here, it tends to go up slightly, so it's slightly positively correlated. And so, essentially that would mean if digestion efficiency goes up, then the weight change increases. So I guess the geese gain weight. Okay, so that's basically that. I'm going to get rid of this chart now. So I'm just going to cut it to remove it out of there. Okay, so part A would be done doing that. Now, for part B of the question, part B, it says find the coefficient of correlation relating weight change y to digestion efficiency x. And then it says interpret the value. So in order to do this, we need to use the formulas for coefficient of correlation. Now, that formula uses a bunch of sum of square values like SSYY, SSXX, SSXY. So we're going to need to be able to figure that out. So I'm going to go to our little writing area and show what that looks like. Okay, so remember the formula for, if we're looking just for the formula for R, we're basically saying that it's going to be the SSXY, the mixed term, divided by the square root of the other two terms, right? So SSXX and SSYY. So we have to actually come up with these quantities. And just a reminder what those quantities involve, let's take just the first one, SSXY. Remember that that quantity will basically be the summation of the XY mixed term, right? So the product of those two values. And then you're going to subtract off the summation of x times the summation of y, basically the product of these two individual sums, right? And then divided by n. Okay, so we need to work out these summation values, and of course each one of these is going to have the same sort of structure. This one will be SSXX, and that'll be the summation of x times x, which is the same as x squared, and then the summation of x times the summation of x over n, right? And then you do the same thing for the next one, SSYY. Of course, that's going to be the summation of y times y. That'll become y squared minus the summation of y times the summation of y, or in other words, the summation of y quantity squared over n, right? So we need these sum values. How are we going to get those? Well, the Excel file will help us do that very easily. We can actually make the columns multiply by themselves. We can make them multiply by another one, and then we can sum them. So we can take care of all these calculations pretty quickly and come up with these values. So I'm going to need these summation values. I'm just going to write them down. So I'll need the summation of x I'll need the summation of y, I'll need the summation of x squared, I'll need the summation of the y squared column, and then I'm going to need the summation of the x times y. Okay, so that's all the unique things I need: x times y, xy, x squared, y squared, and that'll give me everything. And of course, n in the problem needs to be known. They did say we had 42 values in our data set though, so we'll check that, but I'm pretty sure it's going to be 42. Let's go ahead and come up with all these other numbers using Excel then. Okay, so here I am in Excel. We're going to work out these values. And remember, you can do these things by hand or do them with a graphing calculator, etc. It just takes a lot longer, and I believe because they put this data file in Excel and because it was so many values, they intended for you to do this. So, and of course on the test, your professor would have to give you either those summary values that I just listed, or you would have to have a much smaller set of data. There's no way for you to do this all by yourself. So anyways, remember, I changed the positioning here so that we would remember digestive efficiency is your x. So I'm just going to call that here x times x in the top of this column, just to give this a name. X times x will be x squared, right? And then I can do over here, I can do y times y, for example. And then lastly, I can do x times y. This will also give us a blueprint for how to do the calculations. Remember, this will be your x and this is your y. This other column is not needed at this part of the problem. So, all right, so now to fill in these columns, here's what we're going to do. We're going to click the first cell in the column. That's the x times x column, or x squared column. And I'm just going to say equals to, remember, this is our x column. So I'm going to click the first x value, then times. So I hit my little times on my keyboard. That's the Shift 8 button on your keyboard. It looks like a little asterisk. That's going to be our times. And then I click that value again. So I click it twice, and you see that it says E2, E2. E2 is the cell position here, E1, 2, and it's basically multiplying it by itself. Now if I hit enter, and then I go look at that cell, I can see that's the product that I was supposed to get. Now if I just go to the corner of that cell where the cross appears and drag this down, I will get the full product for all 42 of these x values. Alright, I'm going to do the same for the y values. I'm going to say equals to. I'll click the first number in the y position, then times, and I'll do it again, click it one more time, hit enter, and we get the answer 36 like we should get. Negative 6 times negative 6 is 36. If I grab this and pull it all the way down to the bottom, I end up with another full column of product, and that's what I needed. And lastly, I have x times y to do. So x times y means I'm going to do the x value, then hit the times key, and then the y value. And when I press enter, I get that product, and I scroll all the way down. Now remember, you could be doing all this with your calculator by hand, but it just would take a very long time. If you did, you would get the same answers. Okay, so now I have the 3 columns filled in. I need to sum, because what I need is the sum of all of these columns. Each of those things we needed was a sum, so let's go ahead and start with the x column. And I'm just going to put a little statement here. It says equals, and then I'm going to type SUM. I'm going to open a parenthesis, and then I'm going to click the last value in the list and scroll up until I get to the top value of the list. Not the words though, just the number. And then I'm going to press enter. And what it just did is it gives me the sum of all those values, those 42 values. So I have the sum here. And then what I'm going to do after that is just, for convenience, underneath that, I'm going to label that, the x column, just to remind myself that that's x. And then this one would be y. And then this column, remember, was not important to us, and it was starting with this column here. This is our xx column, right? Just so I can see this later, I'm going to do xx. This one's going to be my yy, and this one's going to be my xy. Okay, good. And now to get all the other sums, I can just highlight this corner, grab that corner, and drag it over. And each one of these cells is going to do the same thing. Now, I don't need this sum here, so I could even delete that if that's going to confuse me. And I have the other ones I need. And so now I can go back and fill in my problem. I've basically done all the crunching of the numbers for the table. So now I can just go back into my screen and put all that in. Okay, so we have all our values now, I think. Okay, so coming back from the Excel file, we have the following values. The summation of x was 1,266.5. The summation of y was just 46. The summation of x squared was a pretty large number. It was 57,390.75. Then we'll have the summation of y squared. That was 1,075.5. And then lastly, we have the product of the two values, which was 4,103.25. 5. And remember, n was 42. So we got all these numbers. Now we need to put those numbers into these formulas, right? Or these values in the formula. So we're going to go ahead and do that. Really, for the most part, it's just a simple matter of plugging it in, right? So there's not really a whole lot to think about at this point. Just plug in. And once we have these things, we can get r. So putting the numbers into the formula, we have the mixed term, xy. That number is 4,103.25 minus the sum of x, which is 1,266.5, times the sum of y, which is 46. Then from there, we'll divide by 42. That's our n, right? Our 42. Okay, so we'll work that stuff out quickly in a calculator and see what that gives us. Actually, why don't we fill in all the numbers first, and we'll do all the calculations at once. So let's go ahead and do the next one, which is the summation of xx. And so the x squared quantity is right here, 57,390.75, minus the summation of x times itself, so 1266.5. We can just write squared, right, because it's times itself, and then divide by 42. And then finally we'll have the mixed term, or the y term, pardon me, so SSYY, which is equal to that first value, which is 1075.5 minus the y value squared, and the summation of y squared, and divided by 42 again. Okay, so each of these will have a numerical answer. And let's go ahead and get that with our calculator now. Alright, so here's our calculator. We're just going to type these numbers in as we see them. First number being 4103.25, and I'll subtract off from there this number here, the 1,266.5, 1,266.5 times 46. And then we're going to click divide by 42. So I'm just putting it all in just as I see it. No need for special parentheses or anything. And I hit enter, and I get 2,716. So let's put that down as our first answer. Okay, so that's squeezing that in there, almost running out of space. Let's do the next one then. So our next calculation is going to be, to clear that old one out, the next calculation is going to be the 57,390. So 57,390.75 minus 1266.5 squared. So the squared key on this calculator is here. And then divide by 42. When I do that one, I get 19,199,744. Actually, so we don't run out of room, I'm going to actually put these numbers up here. So 2,116.131, and then for this second one that we just worked out, it was 19,199.744. So 19,199.744, and then this last one we'll do here. Okay, so the last one, we'll clear out the old one, and let's go to work on that one. It's going to be 1,075.5, right? So remember we're doing this one here, minus 46 squared, or you can do 46 times 46 divided by 42. And you get 1,025.119. So the mixed term becomes 1025.119. Okay, so you have your three mixed terms, and you have your summary values here. Now it's time to plug all that information into R. Alright, so I've made some room here to work. We'll have R is equal to, let's plug in the SSXY value, that's just the 2,716.131 number. We're going to divide that by the square root of, first number we're going to need is the X term, which is 19,199.744 times the number next to that, which is going to be the YY value. And we turned out that that number was 1025.119. Okay, so let's go ahead and do 2,716.131 divided by, now for the square root, I'm just going to hit the second key and then the square root. And then I'm going to type in what I see below. It's 19199.744 times 1025.119. And then I just need to close up my parenthesis and press enter. and we get the decimal answer 0.612. And so that's R, that's your correlation coefficient. And it's moderately strong, the 0.612. So in their next part of the problem, they're going to ask us to test that. All right, so that was part B that we did. We did find the coefficient of correlation relating weight change Y to digestion efficiency X. And then it said to interpret the value. So interpreting the value just means as the X value increases. So in this case, as digestion efficiency increases, the weight change increases, meaning the geese tend to get fatter as they digest better, right? As they're more efficient with digestion, they tend to gain more weight. Okay, so part C, it says conduct a test to determine whether the weight change Y is correlated with a digestion efficiency X. So I mentioned that it was 0.6, and that's kind of moderately strong. So it may not reach the threshold, though, to be considered positively correlated. We're going to have to test that using this alpha value of 0.01 and using the procedure to test if there's correlation. So I'm going to go ahead and write that procedure out, and we're going to work it out in the next part of the problem. All right, so there's two kinds of hypotheses we can test here. We can test the first one, which says HO. And so in HO it says that rho is equal to 0. So that's one, standard kind of hypothesis. And if you're using the textbook usually uses just equal to for HO. And then for HA, we'll have the alternative to that. And if I do this one, that rho is not equal to 0, it just says, comparing basically the idea that there's no correlation versus there is some correlation, but it doesn't specify whether it's positive or negative. So I think we should run this test because the problem doesn't specify a particular direction for the correlation. It just says test to see if there is correlation, right? It doesn't say that we should test to see if it's positive. Notice it says conduct a test to determine whether weight change is correlated with digestion efficiency. It doesn't say positively correlated or negatively correlated. If it used any of those two words, I would probably run a one-tailed hypothesis test. And we're going to just put a little note here at the top that alpha is 0.01, and we're going to use this two-tailed procedure. Alright, so from there what you're going to do then is just come up with the test stat. So the test stat is the following formula: T equals to, and you can get this right from your textbook, it's R times the square root of n minus 2. So basically R times the root of the degrees of freedom divided by, and then it's just 1, or the square root of, 1 minus R squared. Alright, and that's equivalent to doing the test stat that we would have done back when we ran the hypothesis test for the slope. So we're basically using the same test stat formula. It just looks different. The notation is different, but it's the same thing. All right, and the reason why we're using this particular version of this is because when you plug in the numbers here, we have all this stuff. We don't need to do too much to do this. We have R. The R is 0.612. The square root of n minus 2. In this case, you have 42 minus 2, right? There were 42 geese. Remember, this n was always 42 in our problem. So 42 minus 2 will give you 40. And then divided by square root of 1 minus r squared. Now, r squared is just 0.612 squared. We probably should have used the full decimal place for this, so not rounding it in any way, but it'll be fine for this, just to demonstrate how it's done. Okay. In fact, we may actually have this number still in our calculator, in which case we won't do any rounding. So let's go ahead and see if we can pull that up now. Yeah, so we actually still have that number in our calculator. What I'm going to do with that is I'm just going to store it as a variable. I'm going to store it as x. And you may not be able to store it, but just copy down more numbers if your calculator doesn't have a store feature. And then let's put that into our formula. Okay, so remember this number is our x in our calculator, so I'm just going to type in x, and then I'm going to do the times the square root of 40, right? In fact, actually, if you want to do it all at once, let's do this. Let's go ahead and put a parentheses around the top of the fraction here. And I'm going to type in, the 0.612, etc., but that's just my x in my calculator. I'm going to hit times. Then I'll press the square root of 40. Now once that's in there, I have to close up the top parenthesis, right? So there's a parenthesis for the square root. I close it up afterwards to close up the big parenthesis there. Then divide by, and then put this square root at the bottom. So square root of 1 minus, that's my x, remember, so x squared. And I just close up that parenthesis at the bottom just once because the square root acts as an overall parenthesis. I press enter, and I get the answer 4.897. 4.897. So t here is equal to 4.897. All right, so there's my t value. And then the last thing to do, of course, is to, compare this to a critical value. And it's just a t-test with n minus 2 degrees of freedom. So we're literally just going to go to our t-table and pull up the degrees of freedom n minus 2. But probably because of this, large t value, we're going to reject the null hypothesis. But let's just check. So I'll draw a little bell curve. And in this bell curve, I'll label a two-tailed rejection region, right? So we'll have a left tail and we'll have a right tail. Remember, we decided to do the two-tailed test. The alpha is 0.01. That means in each tail we'll have half of that, right? So that means we're going to be using 0.005 as our critical value, our alpha value for when we go to the table, because the table is going to look at alpha all in one tail. And let's go figure out what this critical t value is. Remember, the center is at 0, and we're talking about a critical t value. So we need to go to the t table to do that. So I'm coming to my t table here. I'm looking up 0.005. My degrees of freedom in this chapter is going to be n minus 2. Our n was 42. If I take 2 away from that, I'm going to find 40. So let's scroll down, and you can see that in that first column, when the degrees of freedom is 40, the value is 2.704. 2.704. 2.704, and of course negative 2.704. And this test stat is very large compared to that. So this test stat will definitely bring us down over here into the reject HO region. So we will say we should reject HO. Therefore, we should support HA. Remember, those two things go hand in hand. And HA says that the correlation coefficient rho is not equal to 0. So if we're supporting HA, right, and rejecting HO, we're saying HO isn't true. HO is saying there's no correlation. HA is saying there is some kind of correlation. We're supporting that, so we're saying yes, there's correlation between these two variables. Okay, and that's basically it for part C. That would have completed part C. Now they go on to ask you to do parts B and C again. So do the same thing over again, but this time in the problem, just exclude data for trials that use the duck-chow for analysis. So notice they're saying when you come back to our data set here in Excel, any of these that say chow, to ignore them and just kind of delete these data values, repeat all the steps we did using just the one that have plants here. And I guess they're going to see from there if that still shows the same type of results, the correlation is the same or not. I'm not going to redo that here on the video because it just would take too long, but that's essentially all they're asking you to do. They're asking you to do that over and over again. And then they go on in part E and ask you to do the whole thing all over again, but now using two different variables. So using digestion efficiency as your Y and then acid detergent fiber as your X. And they're saying just go through the whole set of data and do all that work over again that we just did. Completely again, and again, that's just creating another huge problem to do, but it's the same skill set as what we just learned how to do. So basically, if you could do parts A, B, and C like we just did now, then you can do all of these parts over and over and over again in any variation that they want you to do.